So we know the sound's working definitely now. Right. So what we're going to have a look at now, going to look at matrix or matrices. Matrix 1, matrices 2. So matrix is fine. I don't really hear people say matrices. So matrix. Now, for this topic, some people have studied this before in high school and some people have not. So what is a matrix? Well, for us, we'll just say a matrix is a grid of numbers that follow special algebra rules. So what I mean by grid is something like this, e.g. 1, 2, 3, 4, 1, 2, 1, 2. These are examples of matrices. It's when you have a block of numbers. And I said that they have their own special rules. So I'm going to show you all the special rules for matrices. So the first rule is how do you add two of them? And that's actually quite easy. If you have, for example, A, B, C, D of numbers and you want to add them to W, X, Y, and Z, you can almost guess the answer. It will be A plus W and B plus X and D plus Y, no, C plus Y and D plus Z. That's how you add two together. So for example, 1, 2, 3, 4 plus 1, 2, 2, 2, that would equal, what would that be? 1 plus 1, 2, 4, 5, 6. So for example, how did I get this 5? Well, that's 3 plus 2. And how did I get this 6? For example, that's 4 plus 2. And then this 2 here is this one and this one. And then 2 plus 2 gives me this one. So you just partner them off. So this is how you add. And what about minus? Well, minus would be exactly the same. If this was minus, then these would be minus. So adding and subtracting is the same. I won't even bother to write the minus down. It's exactly the same as the add. Okay. The next one is called scalar multiply. So that's when you have a number like k and you multiply it by A, B, C, D. And again, you could probably guess what the rule would be. What do you think the rule would be? K, what do you think it would be? K, A, K, B, K, C, K, D. Okay? So we'll do an example, e.g. 2 multiplied by 1, 2, 3, 4. What would that equal? 2, 4, 6, 8. Okay, so that's how you multiply. So we've done adding, subtracting, multiply by a number. Now the last rule that we'll look at is the most difficult rule, and that's how you multiply a matrix and a matrix. So this one is matrix multiply. Very tricky rule. So if we have A, B, C, D, and you want to multiply it by W, X, Y, Z. So watch carefully, please. What you do first is you take this here and multiply it by this. So you get AW plus BY. So A times W plus B times Y. Then for the next one, what you do is you take the same two here and multiply it by these two. What do you get? AX plus BZ. Then you take these two and multiply them by these two. So you get C times W plus D times Y. And in the last one, you take these two and multiply them by these two, and you get C times X. Oh, that colour's not so clear. These two with these two. So you get C times X plus D times Z. And we'll definitely do an example for this. 1, 2, 1, 4 multiplied by 1, 2, 2, 1. Okay, one step at a time. So I take these two and multiply them by these two. 1 times 1, 1. 1 times 2, 2. Add the results together, 3. Then I take these two and multiply them by these two. 1 times 2, 2. 1 times 1, 1. Add them together, 3. Now I take these two and multiply them by these two. 2 times 1, 2. 4 times 2, 8. Add them together, 10. Last one now, I take these two and multiply them by these two. 2 times 2, 4. 4 times 1, 4. Add them together, 8. I'll do another example now. 1, 2, 2, 1. 1, 1, 2, 4. Look at this one now. So I take these two, I'll use a different color. I take these two and multiply them by these two. And so let me ask some people here, what do we get? So Schofield.
Yes.
These two multiply these two, what do I get? You know what it is?
Yes.
Yeah, it'd be 1 times 1 is 1, and then 2 times 2 is 4, and then you add them together, 5 then. Good, okay. Now, let's let's take these two and multiply them by these two. No, let me ask. Jeffrey, what do we get? 1 times 1 is 1, 2 times 4 is 8, add them together, 9. Okay, don't say anything. Right, no, that's not a problem. I want to ask people. Lynn, isn't it? Yes. What are these two multiply these two? So that's 2, 1, and 1, 1. What's that going to be? Try again. 2 times 1 is 2. 1 times 2 is 2. 4. Okay. And Eric, yes. Eric, can you tell me the last one, please? No, 6, yeah. 2 times 1 is 2, and 1 times 4, 6. Now what's strange about my example? Look carefully, please. What do I have here? I have 1, 1, 2, 4. Yes? And what do I have here? 1, 1, 2, 4. Yes? Okay. Now what do I have here? 1, 2, 2, 1. 1, 2, 2, 1. And what do I have here? So these are the same as these two. But is the answer the same? No, it's different. So this gives us an important result. A multiplied by B is not equal to B multiplied by A. And that's actually important for this topic. And there is an example that clearly shows one case when multiplying in a different order gives you a different answer. So in other words, the order is important. The order is very important. Okay. There's one rule left to do, but it's not really a rule. I mean, it's not a new rule, and maybe somebody can figure out what it is. Suppose I have something like this. Example. 1, 2, 2, 1 squared. How would I calculate this? Let's see. Eric, do you have any ideas how I could calculate this? Very good guess, but not right. What about Lynn? Isn't it Lynn? Yeah. Any ideas how we could calculate this?
Double.
Yeah, not the right word, not double. What do you mean? Explain.
2.
Yeah? You mean multiply by 2?
Yeah.
No, not this. Anyone have an idea what we could do? No? Zoe, isn't it? No, I forgot your name. Zoe, isn't it? Yeah, no, sorry, it's still the first week. Do you have any ideas how you could calculate this? No, that's what Eric said, not this. What you can do... to like that. Okay, let me show you. You write it like this. Yeah, ta-da. And now you can calculate. So let's all do it together. This and this, what do I get? 1 times 1 is 1, 2 times 2 is 4, add them together, 5. This one times this one, it will be 2 plus 2, 4. This one and this one will be 2 and 2, 4, and then this one and this one, 4 and 1, 5. And look, this is not 1, 4, 4, 1. So this is one example of a few examples when the order can be swapped. For example, if I swap this one and this one, will it change the answer? Will this change the answer if I swap this and this? No, because they're the same. Like if I swap these, no change, because they're the same. Okay. New page. So I'll just do 2 more examples. Here's actually an easier one because I only have 1 here instead of the 2. I actually should have said here earlier, does anybody know what this is called, these lines? These are called rows. And then this one?
Column.
Oh, very good. Which? Column. Okay. This is actually easier to do because you only have 1 column here. So for example, I do 1 times 2, 1 and 2 times 4 and 1. So what do I get here? 4 plus 2. What do I get? 6. And then I do these 2 with these 2. What do I get? 13. Because you get 3 times 4 plus 1 times 1. So 13. Now look here. What if I try to do this? If I multiply these 2 by these 2, what goes wrong? What's the problem?
No number.
There's no number here.
No.
Okay. So the numbers here must match the numbers here. So how many numbers here? 2. But how many here? 1. So you can't multiply these. The same goes when you try to add. One with 3, that looks okay, and then 2 with nothing, and then what do you add 1 with? There's nothing here as well. Okay, so my point is, in some cases you cannot add, and you cannot minus, and you cannot multiply. I think there's only one case when there's never really a problem. If I have a number, I can multiply it by this, I can multiply it by this, I can multiply it by this. This always works. What do I get here? 2, 2. Come on.
4,
2. And here?
2, 2.
And here?
2, 2.
So this one's quite good. It's the other ones, plus, minus, and multiply, that you sometimes can't do it. Yes.
The last one.
Here?
Going up.
Go up?
Yeah. Why don't you use column multiply?
No, because wait for this one.
Yeah.
Oh, okay. No. The rule is when you multiply, you must always go row
First.
column. It has to be this. There's no choice about it. So you must go row and then column. No choice. Okay. How many people have not studied this before? Jeffrey, Eric, Lynn, have you seen this before? Sorry? Yes, you have?
No.
Well,
No?
last time. with Joan, yeah?
John not teach us this.
Yeah.
No, I mean the whole topic.
Yes.
You've seen it before, yes. And Mohammed, have you seen this before? You have, okay. Yeah, actually, sometimes I forget to mention that you cannot always multiply, that there's sometimes a problem. But you see, in the exam, they're going to give you two things that you can multiply. So in the exam, the type of question you get would be something like, something like this. Straightforward. Okay? Right, let me just have, just a little bit of vocabulary just before we finish here. This one here is called a 2 by 2 matrix because there's two numbers here and two numbers here. Okay? This one here, it's called a column vector. Okay? Size 2. And this one here is called, what do you think this one's called? A row. Now, I use the word vector, and you don't really need this word. But when you learn this topic from a book, they might use the word vector for these, because they're special. And this is size 2. And this one is size 2 by 2. Or, another way to say it is, this is 2 by 2. This one is 2 by 1. And this one's 1 by 2. Now, I'm a little bit tired, so I might have this backwards. I don't remember. So this could be the other way around, but I'm not 100% sure. But don't worry about it, okay? The idea is you have 2 rows and 1 column. Here, 1 row and 2 columns. And here, 2 rows and 2 columns. That's the key idea I'm trying to get to you here. Okay. Let me just have a look at your worksheet. I think I covered everything for it. Yeah, everything's covered.
1001.
We will look at that in more detail in the next class. That's a very special one. I'll show it to you really quick. If I multiply this by this, what's that multiplied by that? It'll just be A. And then when I multiply this by this, I get B. And what ends up happening is when I multiply this one by anything, I always get back the original. Now, don't worry about that. That's not for this lesson. That's for the next lesson. Okay? So it's just Schofield wanted to see this now.
No.
But no.
I know this.
Oh, you know it. All right. Okay. So this we will talk about in the next lesson. This here has a special name. But don't even write it down. That's the next lesson. Okay? So I'd like everybody now to try the worksheet, please.